Hi, this is S. Lakshmanachari, working as Assistant Professor in Department of Cybersecurity, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to discuss the topic computer levels of programming languages. Okay. So, in this lecture, we are going to discuss different levels of programming languages, followed by how the process of compiling and assembling the programs, and finally we will discuss the difference between high level language and low level language. So these are the contents to be discussed here. So a computer is just a machine. So computer is a machine, and it is made up of some electronic devices. That means hardware. So the computer is a machine which is made up of hardware, and that is for executing the programs. That means in order to execute the programs, we have developed it. Okay, so that is a computer. So a computer is just a machine. It is made up of hardware. Then it can be used to execute the programs. And the process of creating the software is called programming. So programming means the process of creating some software. Software is nothing but collection of programs. Program is nothing but a set of instructions. So the process of creating the software, that means a collection of programs, is nothing but the programming. Okay. So these here human languages. Okay. So before seeing to the programming language, then we will see the human language. So what is human language? So human language, it can be used to express feeling and understand the other person expression. So that is the use of the human language. So this human language, it could be a oral or gestural kind of communication. So that is a natural language. So human languages are the natural languages. Okay, and unfortunately, these natural languages are not understood by the computer, because the computer can understand only the machine language. So machine language is nothing but the binary data. Machine language is nothing but zeros and ones. So the computer can understand only the zeros and ones. So this natural language cannot understand by the computer. So we need a special language. So we need a computer languages. So that is the need of the computer language. So computer language is needed in order to communicate with the computer. Okay. So the computer programming languages are divided into different types that are mainly classified into two types. One is a high level language and another one is a low level language. So these are the main classification of the programming languages. So one is a high level language and the second one is a low level language. So again, the low level language, it consists of two types of languages. First one is a assembly language and second one is a machine language. So these are the classification of the programming languages. So then we will see the one by one. So what is a high level language and what is a low level language? So let's start with the high level language. So high level languages are they are very closer to the human language. That means this is a high level language. We are writing the program simply by using some English keywords. Okay, so that's why this high level language, it can be considered as it is very similar to the human language. And the programming languages such as Python, Visual Basic, Java, SQL, C++. So these are all the examples of the high level languages. Okay. So these high level languages, they have been developed to make it easier for programmers to read and write the programs. So that means these high level languages, they have been developed for the benefit of the programmer. That means writing the program in the using the high level language is very easy to understand and to read and write. So that is a main advantage with the high level language, because this high level language is it is very similar to the natural language, human language. Okay. Okay. Then the high level languages are platform independent. So this is another advantage of the high level language. That means high level languages are platform independent. That means suppose if you have a program code that is designed for the computer, the same program code you can use on the another computer with a different microprocessor and with a different operating system we can use. So that is means platform independent. So that means suppose if I have written a program for the um, I have written a program for one microprocessor. So that the same program code I can also use in another computer with a different microprocessor and a different operating system. So that is the benefit of the high level language. And in a high level language must use a interpreter or compiler or translator in order to convert the high level language into the machine understandable code. So when you are writing a program with using the high level language, then we should use this interpreter, compiler or translator in order to convert the program which is in the high level language to the machine understandable language. Okay, so this is about the high level language. So coming to the advantages of the high level language over the low level language. So the high level language, so they are very similar to the English language, so that it is very easy to read and write the programs. Okay, and also the high level language makes complex programming simpler. That means by using this simple keywords, English keywords, then it is very easy to read and write the program. So that even if the program length is large, then it is very easy to read and write the program. So that's why the writing the program in a high level language, it makes very simpler. And high level language is portable. So portable in the sense already we have seen in previous slide. That means the program code which is written for one computer, we can also use the same program on another computer with a different microprocessor and a different operating system. That means no need to change the program. You can run in any computer with a different microprocessors and with a different operating systems. That is called portability of the high level language. Then the length of the program is small when you compare with the low level language. So the length, that means the code size of the high level language is small when you compare with the low level language. Then in real time we are facing so many problems. So all that real time problems we can solve by using the high level language. So these are all the different advantages of the high level language. And coming to the low level language. So low level languages are having lower level of the abstraction. Lower level of abstraction. So because of this, the low level code is more easily read by the computer and they execute at a faster rate. the computers. Okay. And however, this low-level code runs more efficiently. Okay, but it is not efficient for the developers to write, because writing a program in a high-level language is very easy when compared with the low-level language. So the low-level language is very difficult to write and to write the program, to write and read the program. Okay, so that's why this writing a program using low level language is not that much efficient as writing the program in the high level language. Okay, so this low level language are classified into two types. One is a assembly language and another one is a machine language. So this assembly language and machine language are classified under the low level language. So first we will see the assembly language. Okay. So assembly language is the closest language to the machine language. So it is very closest to the machine language, because the machine language is nothing but it is zeros and ones. Similarly, this assembly language also, it is very close to the machine language, because in the assembly language we are writing the program using some mnemonics. Mnemonics means see here. So in the assembly language, suppose if you want to perform the addition operation, then we can use the mnemonic add. Suppose if you want to perform subtraction, you can use subtraction, sub. If you want to compare, then we can use this CMP, compare. So like that, for every operation we have some mnemonic. Using that mnemonic, we will perform that particular operation. So this mnemonics in binary, it is having some format. So like some 10, so like that. So that's why this assembly language is very close to the machine language. So however, the assembly languages are converted into the machine language by using the assembler. So this assembly language, it directly the microprocessor cannot understand. So that's why we need to convert the program from the assembly language to the machine understandable language. So that we can do with the help of the assembler. So assembler, it converts the assembly language program into the machine understandable language. So that is called the assembler. So it converts assembly language instructions into the machine code. That is with the help of the assembler. Okay. And each processor has its own assembly language. So that means so we are using different types of processor, like Pentium processor, 8085, 8086, 80286, 386, 80486, Pentium Pro, Pentium 2, 3. So like that, different processors are there. So all these different processors, they are having their own set of instruction set. That means they are having their own instructions. Okay. Okay. So the program written in assembly language of one microprocessor cannot use for the other microprocessor, because already we have seen every processor, they are having their unique instruction set. That means the instructions of one microprocessor are not similar to the another microprocessor. So that's why, suppose if I have written a program for 8086. Okay. So this is a one Intel processor. So suppose after writing a program for the Intel 8086, the same program I cannot use for the processor AMD processor, because their process instruction set is different. Intel processor is different from the AMD processor. So that's why the instruction set is different. So that's why the same program we cannot use for the other microprocessors. But we can use with one very important exception. That is, a company that develops microprocessors will usually design a new microprocessor. So that they are backward compatible with its previous microprocessor. So that means, suppose if you consider an example of Pentium 3 microprocessor. So Pentium 3 is a microprocessor. So suppose if we write a program for the Pentium 3 microprocessor. So that means, the program which is written for its previous, the program which is written for its previous backward compatible process, like what are its previous microprocessors, like Pentium 2, Pentium 2 Pro, Pentium 2, 80486, 80386, 80286, 8086. So these are all the backward compatible microprocessors. So the programs of the program written in assembly language of all these backward compatible microprocessors we can use for the Pentium 3 microprocessor also. Okay, so this is a assembly language. And coming to the machine language. Machine language or machine code is the only language that the computers can understand. Only the computers can understand the machine language. Machine language is nothing but zeros and ones only. So these machine languages are often either binary or hexadecimal. So these instructions we are represented only in the form of binary number system or hexadecimal code. And the binary is a system of using only the zeros and ones. So already we have seen. Okay, so these zeros and ones are used in order to represent some text or characters, text and everything else that can appear on the computer's screen. Okay, so even any type of information that can be represented using only the zeros and ones in the machine language. And programmers do not write the programs in the machine language, because the writing a program, writing and reading the machine language is very difficult. Okay, it is very difficult. So rather than the programs written in the high level language or assembly language. So reading and writing of machine language is very difficult. So that's why we are using assembly language or the high level language, because the assembly language or high level language that are very easy to read and write the programs. And here you can see the example of binary code. So suppose if you have a hello, hello we have written in the English. So we can easily understand that hello. But if we represent the same hello in the binary code, so H it can be represented like this. So 0 1 1 0 1 0 0. Okay, so this is just for understanding. So let us suppose if the binary code for the H is like this. So if you look into that binary code, we cannot say what is that. That is very difficult to read and write. So that's why the machine language is very difficult to read and write the program. Okay. Similarly, E can be represented like this, L, O. Okay. So these are the way of representing the binary code. And coming to the compiling and assembling the programs. So once we have written the program in the high level language or assembly language, then that programs can be converted into the machine understandable program, machine understandable code. So that is called compiling and assembling. So that means see, suppose if you have written a program using the high level language, so that high level language should be converted into the machine understandable language. So this conversion will be done by a compiler. So compiler will convert the program from the high level language to the assembly to the machine understandable code. So that is called compiler. Similarly, we can also write the program using assembly language. So assembly language is nothing but writing a program using mnemonics. So that means once we have written the program using assembly language, then that should be converted into the machine understandable language or machine understandable code. So that we can do with the assembler. So assembler. Okay. So the process of converting the high level language into the machine understandable code, that is called compiling. Compiling. The process of converting the assembly language program into the machine understandable code, that is called assembly. So these are the compiling and assembling. So we will see different steps of the compiling. Okay. A program that changes source code to the object code, that can be executed by a machine. So we are writing a source code. Source code means here the high level language program. So the program which is written in the high level language, that should be converted into the this object code. Object code is nothing but the machine understandable code. Okay. And this compiler, so before compiling, the compiler will checks the code, checks the program code. So if all the syntaxes of the program are valid, then the compiler will do the compiling. And also it checks all the program at a time. At a time, it checks entire program at a time. Okay. So initially it checks for any syntax errors. If any syntax errors are there, the compilation will not do. It will not do the compilation. So the compilation will done only when we have a error-free code. Okay. So what is the primary reason for the compilation? In order to convert, the primary reason is to convert the high level language program to the machine language code. That is the main purpose of using the compilation. And examples of compile based languages are C, C++, Java, SQL, Visual Basic. So these are all the different examples of the compiler based programming languages. Okay. So here you can see, so it is a compiler. Okay. So the input to the compiler is the source code, that is nothing but high level language. So that high level language, it should be converted into the machine understandable code. Okay. Then that machine understandable code we are giving to the processor. Then the processor can understand and it performs that particular action. Okay. So a program written in high level language is input to the compiler. So source file is the source program is it is an input to the compiler, and it checks the program to make sure every statement in the program is valid. Then it checks the any syntax errors. If no syntax errors are there, then it will do the compilation successfully. Then finally it will generate a object code. That object code we are giving to the processor in order to execute the program. So these are the different compiler, linker, loader. So the source code we are giving to the compiler, it converts into object file. So source code means here high level language that it will be converted into the machine understandable, that will be converted into the machine code. Okay, then it is a linker. So linker means finally it will send it will generate the compiler will generate a object file. That object file, it is not suitable to give to the microprocessor. So it needs to be add some library files and other files also. So that's why using the linker, we will add some other library files and supporting files. Then we are giving to the loader. So loader will place that particular program in the memory. From the memory, that particular program will be executed. So operating system will execute that program from the memory. So this is how a program from the high level language will be converted into the machine understandable code. So this is a assembly process. Assembly process. So initially we have a assembler. So for the assembler, we are giving assembly language program. So assembly language program is it is an input to the assembler. Then assembler, it will convert it into the machine language module. Machine language module. Then with the help of the linker, we will add some other library files. Then finally it will generate a machine language program that will be given to the loader. The loader will place that machine equivalent code in the memory. From the memory, the operating system will execute the program. So this is how the high level language program will be converted into the machine understandable language. So this is a assembly process. So now we will see the difference between the high level language and the low level language. So already we have seen what is a high level language and the low level language. So high level language is having high degree of high level language, and so first parameter. So we are comparing this high level language with the low level language. So high level language is having high level of abstraction, and similarly the low level language is having the low level of abstraction. So first one is a hardware knowledge. So when we are writing the program in the high level language, the programmer should not require the hardware knowledge. So without knowing the hardware, then we can write the high level language, because it is a hardware independent language. So no need of knowledge of the hardware. But when we are writing the program using low level language, then the programmer should aware the hardware. Next, easy of learning. So high level language program, it is very easy to learn, easy to read and write the program. It is very easy to understand and learn. But the low level language program, it is somewhat very difficult to understand the program and also for writing the program. On performance. So performance is high level language programs are slow performance and faster than high level language. And examples of the high level language are C, C++, Java, SQL, Visual Basic. So these are all the different examples of the high level language. And the low level languages are machine language, assembly language. So these are all the different examples of the low level language. And coming to the translation. So the programs written in high level language, it doesn't require any translation. Okay. It requires a translation. Okay, because here in the high level language we are using some compilers. So compilers will convert high level language program into the machine understandable language. So that's why for the high level language programs we require translators or compilers. Here low level language programs it doesn't require any translators. And execution. The programs in high level language are slow in execution. Okay, because the high level language programs are very lengthy, so that's why it takes more time to execute. So that's why the programs in high level languages are slow in execution. And the difficulty of modification. Okay, programs in low level language are fast in execution because here these low level language program code will be executed at a very faster rate. And modification. So easy of modification for programmers written in high level language because the high level language program, it is very similar to the human language. Simply by looking into the program, we can understand the program very easily, so that it is very easy to modify the content of the program. And coming to the low level language, so low level language modification, it takes more time because the programmer should understand the logic of the program. Then he or she needs to be modify the program. So the modification of the programs written in the low level language are difficult. Abstraction. So high level language allows more abstraction, and the low level languages are these are very little to negligible abstraction. Hardware level proximity. So many facilities not provided at a hardware level, and supportive of writing program at a hardware level because the high level language programs are hardware independent, and the low level language programs are hardware dependent. That means the hardware knowledge is required when you are writing the programs using low level language. And memory usage. So memory usage for the high level language is more because the length of the program is more. So that's why it requires more space. But for low level language program, it requires less memory area. So these are the different differences between the high level language and the low level language. Okay. So in this lecture, we have discussed different levels of programming languages. Then we have seen how the programs can be compiled and assembled. Then finally we have seen the difference between high level language program and low level language program. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.